Hello everyone. Today I am your host Aishwarya Srinivasan and welcome to PyTorch Lightning Community Spotlight. I'm super excited to have Shamane today as our guest, who is a PhD student working on information retrieval and natural language understanding at University of Auckland. I'm really glad to have you here, Shamane. I would really want to know more about your project, which you did around RAG, and I am absolutely new to this concept, so I would really expect you to help me understand more about this and talk to us more about what you did in the project.
Yeah, so first, I'm working on natural language understanding in University of Auckland. So this is like I'm into the second part of my PhD, and here I mainly kind of extend the RAG model. There's an amazing implementation in Hugging Face. I kind of extend it with PyTorch Lightning. So I'll start with this like very simple introduction to RAG models. Yeah, so the RAG models mainly illustrate on how to combine the idea of information retrieval and language modeling in an end-to-end manner.
Mhm.
So they consist of like mainly three parts, where the first part is um, you encode your input.
Mhm.
Then there's a retriever that you use that input and kind of retrieve most important or most relevant set of information. Then
Okay.
you use this set of information and try to generate the output. So the good thing about this kind of models are they are kind of going beyond that black box concept, and you really can access to this external knowledge base.
Got it.
And also, like recent work mention these kind of like retrieval augment models
Mhm.
can reduce the hallucinations in
Interesting.
general like sequence language models, right?
Hmm. Yeah.
So so in my work, I mainly work on this retrieval part. I wanted to make this like entirely end to end.
Hmm.
So the retriever part consists of like two things. You can see it encodes the question, and
Hmm.
it has this encoded set of documents, right? So if I like quickly show easier image, this is what it looks like. So you
Hmm.
have an input, and you have this set of documents or whatever the context encoded, right?
Hmm.
So the original RAG only fine tunes this part, the question encoder and the generator, but not this document encoder. That means they do not update the output, update this external document set or the external knowledge base while during the training, right? So this part kept frozen, only the question encoder and the generator.
Got it.
But in, like parallel work like real kind of shows it would be nice if we keep updating this knowledge base also, something like that, right?
Yeah.
So
Got
that's the entire idea. So this actually motivated me, like, because I wanted to use this for very much domain specific data.
it. Okay.
And then the so it's really easy engineering, like theoretical point of view, it's kind of really easy. You don't even need to tweak your loss function anything, but engineering wise it's really hard, because this part here, like the retrieval part is really some some kind of like computationally expensive thing, because you just imagine your external knowledge base consists of let's say uh, millions of documents, right?
Mhm.
So you have these millions of vectors, and during the training time, you need to find the most important things. So you need to always use some kind of maximum inner product search library like Fairsys or Scan.
Mhm.
And now on top of it, if you want to update this external set of document,
Mhm.
the problem is while you have this training process going, you need to again re-encode in every each and every document. So this is more like you have millions of documents and you need to send them again through a BERT or something.
Got it.
So if you stop your training process,
Mm-hmm.
let this finish, so it might take ages. So you like practically you can't kind of do this while you are like you can't do this while interrupting the training process, right?
Got it.
So
Yeah. Mm-hmm.
so like one possible method to overcome this challenge is you have this back propagation or the distributed data parallel usual training process going on,
Mm-hmm.
and you kind of implement another asynchronous process that updates this document index. So it is kind of perfect. So what it does is the once in a while it uses this updated document encoder. That means it uses this updated passive this BERT model or something, and then kind of different process send your knowledge base through this updated context encoder,
Mm-hmm.
and then re-index it. So this is the problem I was really interested in. So I wanted to like do this without interrupting the training process.
Got it.
This is where the PyTorch Lightning came
Mm-hmm.
really handy to me. So with PyTorch Lightning, the beautiful thing is you have these amazing hook functions. So you just go to the training step, and like now your DDP process is running, right? Let's say you
Yeah.
have 8 GPUs, so
Mm-hmm.
it's been training, but you need to call these parallel processors like that encodes these documents or whatever it is. So
Mm-hmm.
you are not using any GPUs that being used in the training process, right? Because
Got
you
it.
don't need to interrupt.
Yeah.
So what you do is like you need to call, okay, after let's say after 500 steps you need to start re-encoding your external document base, something like that, right?
Yeah.
By using these DDP things, like this training step inside then different ranking systems, you can kind of access easily to the DDP process, and
Got it.
then only focused on what you really want to improve.
Got it. Got it. Makes sense. So,
Yeah.
what would be like if I were to ask you what was the best practices that you would recommend when somebody is using PyTorch Lightning? What would that be?
So the so I'm always trying to kind of align with, because PyTorch Lightning kind of changed a little bit over last few months. So I
Mm-hmm.
would say it's really important to stay up to date, because they had this, like for example plugins, they
Yeah.
had this experimental thing. So I'm
Yeah.
saying maybe always get updated with the recent documentation.
Mm-hmm.
And then what I would say is like, especially what Hugging Face does, I really like,
Mm-hmm.
keep a lightning base, like a script that lightning base maybe consist of this optimization configuration and everything. So it's really easy. So for the other project you don't have to worry.
Yeah.
And then now I think there's this tutorial, right? Entire tutorial how you can plug the Hugging Face model to PyTorch. I
Mm-hmm.
would say like current NLP, even for the PhDs, it's all about implementation, I certainly believe, because bigger models are really working well, and you really need to make sure you kind of you make use of these pre-trained models, and then you need a better code, right?
Yeah.
Which is
Yeah.
kind of
Agreed.
easily extendable code. I
Yeah.
would say PyTorch Lightning certainly helps. So when you are trying to start a new project, kind of follow these tutorials or the baselines, which
Mm-hmm.
will make your life like 100 times easier in future. Maybe it might be with why should I do this and that, but it really helps you to narrow down your work. Yeah,
Yeah, absolutely, absolutely. So thank you so much, Amane, for like joining us today, and
yeah,
thank you everyone for watching this community talks. And you can go check out PyTorch Lightning on the GitHub page, or you can follow us on Twitter, which is at the rate PyTorch Lightning without a G. And if you have any more questions, feel free to ping us on our community page. Thank you so much, and thank you so much, Amane, as well.
yeah. Thank you very much.